This is an example of a stoichiometry problem with a limiting reactant. In this problem, we're given an equation, which has already been balanced for us, and two amounts of the reactants. Now, we aren't told if both reactants are used up completely or if we have extra of one of those. And that's what separates a limiting reactant problem from our ideal stoichiometry problems that we worked on earlier. So to start this problem, I need to figure out which of these two is the limiting reactant. Am I going to use up all 36.0 grams of water and have extra iron, or am I going to use up all 67.0 grams of iron and have extra water? So another way to look at this is which one do we have extra of, which we call the excess reactant. We can solve this two different ways. Either I can make the assumption that I'm reacting 36 grams of water and try and figure out how many grams of iron I would need to completely react all that water. Or I can look at if I'm reacting 67 grams of iron, how much water would it take to react that, and then compare it to the amounts that I actually have. So let's look at how much iron we'd have to have if we had 36.0 grams of water. So we'll start out with 36.0 grams of H2O, and I want to figure out, to react that all together, how many grams of iron am I going to have? Am I going to need? This is a multi-step conversion because we don't have a relationship for masses of these compounds, just like we talked about with the ideal stoichiometry problems. So instead we have to go through moles. So I'll start by figuring out how many moles of water this 36 grams would be equivalent to. From there we can figure out how many moles of iron we would need, and we can convert that then into how many grams of iron we would need. So we set this up as a dimensional analysis problem. 36.0 grams of H2O is our given information, so we write that first, times, and then we'll have some fraction. We need to convert from grams of water to moles. Right now I have grams of H2O up on top. I want that to cancel, so I'll put that on the bottom, and I want to go to moles of H2O. The conversion between moles and grams for any compound is 1 mole to the molar mass for that compound. So 1 mole of H2O in this case is the same as 18.0148 grams, which I get from the periodic table. Hydrogen has a mass of slightly over 1, oxygen has a mass of slightly under 16. So 2 hydrogens and 1 oxygen would together have a mass of slightly over 18 grams. Now my grams of H2O cancel. I'm left with moles of H2O. I want to keep converting to get my next step, which would go from moles of H2O, I want that to cancel, so it goes in the bottom, to moles of iron. And from the balanced equation up here, I can see that I have, for every 3 moles of iron, 4 moles of water. So I can fill that in here. And my last step, after these cancel, I need to go from moles of iron to grams of iron. Multiply by moles of iron on bottom so that it cancels, grams of iron on top, and in 1 mole of iron from the periodic table, I see we have 55.845 grams of iron. Moles of iron cancel, and when we plug this into the calculator, we get an answer of 83.7 grams of iron. So what this means is that in order to react 36 grams of water completely, I would need 83.7 grams of iron. But I don't have 83.7 grams of iron. I only have 67 grams of iron. That tells me that I don't have enough iron to react all of this water. So there's going to be some water left over that doesn't get reacted. That means that water is my excess reactant, and iron is my limiting reactant. So to answer the question, what is the limiting reactant? Here it would be iron. The next part of our problem asks us, given these two amounts of water and iron that are being put together, how much Fe3O4, how much iron oxide, will be produced. So in this problem, we saw that iron was our limiting reactant. Once our iron is used up, we can't do any more reactions. So we're going to use the amount of iron that was given to us to calculate how much iron 4 oxide is going to be produced. So that was 67.0 grams of iron. And again, we want to convert this, or do the stoichiometry for this, to get to how many grams of Fe3O4 are going to be produced. Just like in the last step, we can't go directly there. We have to start by going to moles of iron, then moles of iron oxide, and then grams of iron oxide. So we'll start out with what we know, 67.0 grams of iron. I want to get rid of grams of iron, so I'll put that in the bottom, so it'll cancel with the grams of iron up top. Next step will be moles of iron. 1 mole of iron is the same as 55.845 grams of iron. That's off the periodic table. Grams of iron cancel, leaves me with moles of iron. I want to get rid of moles of iron, so I put that down in the bottom because it's up in the top to start. And I want to get to moles of Fe3O4. From the balanced equation, I can see that for every 3 irons I have, I get 1 iron oxide. So 1 iron oxide to 3 moles of iron. Times, let's see, my moles of iron cancel. I want to get from moles now to grams of Fe3O4. So that would be moles of Fe3O4 goes on the bottom. And I want grams of Fe3O4 goes up top. 1 mole of Fe3O4 has a mass of 231.531 grams. Again, off the periodic table, the mass of 3 irons plus the mass of 4 oxygens. Moles of Fe3O4 cancel and leaves me with grams of Fe3O4. And on this one, when I put that into my calculator, we get an answer of 92.6 grams of Fe3O4. The last question in this example asks us, for that excess reactant, which in this case was water, how much are we going to have left over after we've reacted all that we can with the iron? In order to solve that, we first need to figure out how much of our water is going to be reacted. So I know that I'm reacting 67.0 grams of iron. I don't know how much of that water is going to be reacted. So that'll be my first step, is to figure out how many grams of water are going to be reacted, and then I can subtract that amount from my total amount of water, which was 36 grams, to figure out how much is left over. So here I need to go from 67.0 grams of iron to figure out how many grams of H2O we're going to use in this reaction. So again, start with what we know, 67.0 grams of iron times, we'll put grams of iron at the bottom, moles of iron up at the top. 1 mole of iron is equivalent to 55.845 grams of iron. Grams cancel. Multiply by moles of iron on the bottom to get those to cancel. We want to get to water, so moles of H2O goes up on top. And for every 3 moles of water we have, we need 4 moles of H2O. and again that comes from our balanced equation, 3Fe plus 4H2O. Now our moles of Fe cancel. Last step, we go from moles of water to grams of water. And 1 mole of water has a mass of 18.0148 grams. When I plug this into my calculator, I get 28.8 grams of water. Now that isn't our final answer here. That's how much water is reacted, how much is used in this reaction. But it didn't ask me for that. It asked how much is left over. So to get that, I know that I started with 36.0 grams of water. It's present. Some of it's going to be used for the reaction, some of it isn't, it's just there. We're going to subtract 28.8 grams of water that was reacted, and that'll leave us with 7.2 grams unreacted.